These are the practice problems for lesson 7, representations of linear relationships. And in problem number 1, you have 2 recipes. The information for one recipe is given to you in the form of an equation. The information of the second recipe is given to you in the form of a table. And for both of these recipes, the first part of this problem is to figure out how much flour you need in that recipe if you're given 4 cups of sugar. So X is equal to 4 cups of sugar. And so the sugar is X and the flour is Y. So notice that that 7/4 tells you how many times different the cups of sugar are. The X value is, how many times different the Y value is than the X value. So Y is 7/4 times the cups of sugar. So it's 7/4 times different than the amount of sugar. So the change in sugar is 4 cups. The change in Y is 7/4 times that 4 cups. Well, 7/4 times 4 is equal to 7 cups of flour. Notice that it's almost twice as much because 7/4 is very close to 8/4, which is 2. So 2 times 4 would be equal to 8, a little bit less than that. It's 1/4 less than that, so it's 7/4 times 4 gives you 7 cups of flour. In the second recipe, again, the sugar is going to be the X value, so it's the information in the left column, and the flour is going to be the Y value, so the information in the right column. And to go from the cups of sugar to the cups of flour, you're going to multiply by the constant of proportionality. That tells you how many times different Y is than X. It's using that constant of proportionality. And so how do you figure out that constant of proportionality? How do you figure out how many times different Y is than X? You divide Y by X. That tells you how many of these X's you need to get to Y, or how many times different Y is than this X. Well, you take the 3/4, which is Y, and you divide it by the 1/2. You do that division, it's 3/4 divided by 1/2. To solve it, you multiply by the reciprocal, you use the inverse operation. So this once again is the inverse and the inverse. Inverse operation and multiplicative inverse, which is the reciprocal. So 3/4 times 2 is equal to 3/2. And here's how you simplify that right here. So what that tells you is that the number of cups of flour is 3/2 greater than the number of cups of sugar. So it's 3/2 of the cups of sugar. So it's going to be more flour than sugar because this number is greater than 1. So you can check that by using these values down here. And it should come out to be 3/2 just as well, because this is a constant of proportionality. So every time you divide Y by X, it has to equal, for this problem, it has to equal 3/2. Well, 9/2 divided by 3, 4.5 is the same as 9/2 divided by this 3 is 9/2 divided by 3 is the same as 9/2 times 1/3. So again, the inverse and the inverse. So 9/2 times 1/3. The way to simplify that is shown right here. 3 times 3 divided by 3 times 2. The common factors cancel out and you're left with 3/2. So once again, if you look at this, 3/2 of 3 has to equal 4.5. Well, 1/2 of 3 is 1.5. 2/2 of 3 is 3. 3/2 of 3 is another 1.5, or 4 1/2. So 1/2 of 1/2 is 1/4. 2/2 of 1/2 is 1. And another 1/2 of 1/2 is another 4. So it's 3/4. So you get 3/4. And so how much flour do you use given 4 cups of sugar? You're going to use 3/2 of as much flour as cups of sugar. So 3/2 of 4, 1/2 of 4 is 2. So that goes 2, and then 2 is 2/2, and then 4 is 2/2, and then 6 is 3/2. So it goes 2, 4, 6. 1/2 of 4, 2/2 of 4, 3/2 of 4. So 3/2 of 4 is equal to 6 cups of flour. 4 divided by 2 is 2. 2 times 3 is 6. And you can check that. So now remember, the 3/2 is the constant of proportionality. That means that the amount of flour is going to change by that constant. You're going to multiply it by that constant each time. In this case, the amount of flour is greater because the constant of proportionality is a number larger than 1. So the equation is y equals 3/2 x. So y is equal to the constant of proportionality, k, times x. And in this case, that answer is 6 cups of flour. And you can check it one last time using this middle row, 3 3/4, which is 15/4. 4 times 3 is 12, plus 3 is 15/4, divided by 5/2. 2 times 2 is 4. So you get 4/2 out of 2, plus 1 more half is 5/2. If you divide those, you're going to multiply by the reciprocal. So 15/4 times 2/5. And so you can write out these factors, cancel out the common factors, and again, you end up with 3/2. And so here it all is on one page. And notice that the recipe on the left, the recipe given by the table, is sweeter. It's more sweet than the recipe on the right because for the same amount of sugar, 4 cups, you use less flour. So that makes this recipe sweeter. You use the same amount of sugar, 4 cups, you use more flour on this side. So this recipe is less sweet. And down here, what does the constant of proportionality mean? It means that the units of y are 3/2 of the constant of proportionality is 3/2, 3/2 of the units of x. So whatever units of x you have, you multiply that by 3/2. That's going to tell you what the units of y are. On the right side, whatever the units of x you have, you multiply it by 7/4. That's going to tell you what the units of y are. And 7/4 is larger than 3/2. This is 1 1/2. This is 1 3/4. So it's actually 1/4 larger. 7/4 is. So constant of proportionality tells you how much you have to multiply x by to get to y. It tells you how many times different x, or how many times different y is than x. Okay, problem number 2. They want you to show using either a series of transformations, so a rotation, a translation, or a reflection, and dilations, so a series of transformations and dilations to show that you can move this image, E, F, G, H, to exactly cover this image, A, B, C, D. If you can do that, then that proves that this image, A, B, C, D, is a scaled copy of this image, E, F, G, H. So what I'm going to do first is I'm going to identify H as the center of dilation. And I'm going to use a scale factor of 1/2. So I'm going to bring each of these points closer to H by multiplying the length along the rays out from the points by 1/2. So for E, that brings that point to this point right here, which is half the distance. For F, this point moves in half the distance from H to right here. For G, this point moves in half the distance to H, that's right here. Connect these 3 points, and you get this blue image that's E prime, F prime, G prime, and I should label this H prime. All right, so that's the scaled copy. And so now what I'm going to do is translate this so that G prime covers C. So I translate it over, C prime, G prime covers C. So each of these other points have to move the same direction and the same distance. They have to move with this point that moves from G prime to C. So once you're here, you might see that this is the line of reflection right here. And so to get this blue image to cover exactly this image A, B, C, D, you're going to move each of the corresponding points in a perpendicular direction, which means at a 90-degree angle and an equal distance away from the corresponding point. You do that for each of these points, and they cover image or A, B, C, D exactly. So that proves to you that E, F, G, H is in fact a scale copy of A, B, C, D. So this is problem number 2. Problem number 3. They give you 3 slopes, and they want you to write the equation for those 3 slopes and also draw the line, and draw that line by changing the y-intercept. So you have the slope and the y-intercept, where each of these lines is going to cross the y-axis. So we're going to get to that in just a moment. But we're going to treat each of these in the beginning as proportional relationships. So that means they go through the origin. So they follow this equation, y equals kx, and that k is the constant of proportionality, and that is the slope. So what that tells you, that if you use this graph, the lowest one here, this is y equals 1/5 x. So y changes by 1/5 the amount of x. So whatever x is, and x is going to be 5 in each case, because that's the easiest value to choose because the denominator is 5. I'm going to choose 5 as the value for x. That tells you that y is 1/5 that 5. So y is only 1 unit. So y is equal to 1/5 x. But notice for this one's rising faster. It's at a steeper slant, a steeper slope, because this slope, or this constant of proportionality, is 3/5. So for 5 units, the length in the vertical direction is going to be 3 units. It's 3/5 whatever the length is you have in the horizontal direction. And notice it's also 3 times greater than this first line. Slants, or the slope is 3 times greater, so it slants 3 times greater. And the last one is 6/5. So this is going to be 6 times greater than the first line. It's going to be it's going to have a slant that's twice as much as the second line. So for 5 units in the horizontal direction, so a 5-unit change, a horizontal change, is a 6-unit change for the vertical direction. So it's 6/5 of whatever the x value is. The x value is 5, so you multiply that times 6/5, and you get an answer of 6 units. So this one is increasing the fastest. This one's increasing the slowest, because this has the smallest slope. This has the greatest slope. So now if you change, so I'm going to get rid of the slope triangles, and I'm just going to use the points here. And if you change where they cross the y-axis, so all I'm doing is taking this graph and sliding it up 1 unit, taking this graph and sliding it up 2 units, and taking this graph and sliding this graph up 7 units. So the y-intercept is this beginning value, so where it starts. So the first graph is y is equal to 1/5 x. That's where we started. But now you have to add that 1. So to get this coordinate y, if you're given a value for x, to get the y coordinate for that point right there, you have to take 1/5 the value of x, and you have to add this 1 to it. To get this point right here, you have to take 6/5 the value for x, and you have to add 2 to it to get to the y value. You know that the x value is 5 because you're going out here to 5, and to get to the y value for this point, you have to multiply it by 3/5, but then add 7 to it, because now it has a head start of 7 units. So the y-intercept is 1, 2, or 7. And notice that the graph that starts at 2 catches the graph that starts at 7. They intersect way up here. And then the graph that starts at 2 is greater and greater as it passes that, because its slope is greater. So it's increasing at a faster rate than this line right here, But notice that the line that starts at 1 will never catch either the line that starts at 2 or the line that starts at 7, because it's not rising as fast as either one of these. So it's going to continue out here. It's going to continue to rise, but it will never catch either the one that starts at 2 or the one that starts at 7. And again, I got rid of the slope triangles, and I'm just trying to use the points now because that's the direction we're going, and that's what we're going to do in the next problem, which is problem number 4, the last problem. This problem is a plant that's planted, and when it gets planted, it has a certain height, and then they measure the height of that plant after they plant it each month. So what's the height of the plant after each month? And they find that it increases proportionally to the number of months that they have measured it. And so they want you to write an equation for this line, just using just these points. Now, they don't give you these points. I'm going to tell you why I chose those in just a moment. But then they want you to figure out what the height of the plant is. I'm sorry, how many months it takes for that plant to reach a height of 66 inches. All right, so why choose these 2 points? Because they cross, the line intersects the grid lines going vertically and the grid line going horizontally. So I wanted to use that point because I know for a fact that the x value, or the number of months, is 1 month, and the height in inches is 15 inches. There's no question about that. I still don't know where this point crosses the y-axis yet. I don't have enough information to say what it is. I know it's between 10 and 15, but I don't know if it's 11, 12, 13, 14, or a fraction of one of those values. I don't know. And out here at 6 months, it has grown to 30 inches. And I know that for a fact. There's no doubt, because the graph crosses this intersection of 30 inches and 6 months. So now we're going to use these 2 points to write the equation. And so you want to get, first thing you want to do is get the slope of that line. So how much is that line changing in the vertical direction compared to its change in the horizontal direction? So it starts at 15, so you go out here to 6 and you go up to 15. So it starts right here. So I'm kind of using the slope triangle, but I'm not going to draw it in anymore. So it starts at 15, and where does it end? It ends at that 30 right there. So to figure out its change, you subtract that 15 from the 30. So it's 30 minus 15. And pretty soon you won't even use this point. You realize that that 15 right there is the same as that 15 right there. So 30 minus 15, this point is 15 units up the y-axis, is equal to a change in the y direction of 15 units. 30 minus 15 equals 15. So what's the horizontal change? This horizontal change starts at 1 and it ends at 6. So how far has it gone in the horizontal direction? Well, that's 6 minus this 1, or 5 units. So the horizontal change is 5 units. This length right here is 5 units. And pretty soon, once again, you won't use this point. You realize that this point up here, 6, has moved over 5 units from this 1. So this 1, you can also look at it as going up to here and moving over 5 units to end up here. But pretty soon you just subtract 6 minus 1, and so that horizontal change is 5 units. And so what's the relationship between those two? Well, the vertical change is 15/5. So the vertical change is 15/5 of the horizontal change. Well, 15 divided by 5 is 3. So the vertical change is 3 times the horizontal change. Does that make sense? This is one of the reasons that I don't like to talk about units, the lengths of the size. Rather, I'd like to talk about just the units, because these units are 15 units in inches of height compared to just 5 months. So these units, 15 units, is 3 times greater than the number of months. It's 5 months. 3 times 5 is 15 inches that it's grown in those 5 months. So the change in y compared to the change in x, which is the slope, is 3 inches for each month. So now we can figure out that this point right here is in fact 12. Because if this is a slope of 3, I can go backwards. In this 1 month, it's grown 3 inches. So if I go back 3 inches from 15, 15 minus 3 is 12 inches, and go back 1 month, that point right there is in fact 12. So now we have enough information to say that. But you can also figure out the equation. So I want you to practice writing the equation, and you can use 6 and 30 as x and y. So how do you figure that equation out? You figure out what's the vertical change, which is y minus 15. So this is y minus 15, this y minus this 15, which is the same as this 15. So y minus 15 compared to the horizontal change, which is x minus 1. So that 6 is x minus 1. So that ratio, so y minus 15, the vertical change is 3 times, we already figured out the slope, is 3 times the horizontal change. And we use the example of 15 is 3 times 5. So if you know that, so the vertical change, y minus 15, is 3 times the horizontal change, then you can just write the equation like this and use the distributive property to multiply this out. So if I have 3x minus 1s, that tells me I have 3 x's, and I have 3 times 1, or I have to subtract 3. If I subtract 1 3 times, it's the same as subtracting 3. So y minus 15, if I want to figure out what is the y coordinate if I'm given 6 as the x coordinate, well, what I have to do is I have to add that 15 back. So I have to add this 15. So y is equal to 3x. I add the 15, but I still have to subtract this 3. So 15 minus 3 gets me to this 12, which is the vertical intercept. It's right there. So if I'm given an x value of 6, to figure out what the y coordinate is for this point, I have to multiply 6 times 3. 3 times 6 is 18, and 18 plus this 12 that I have as a head start is going to get me to 30. So if I'm given a value of 6, I'm going to end up at 30. If I'm given a value of 1, 3 times 1 is 3, plus 12 is 15. So if I'm given a value of 1, then the vertical change is 3 times that 1, plus I have to add the 15 head start. So 3 plus 12. I have to add the 12 as a head start, sorry. So 3 plus that 12 gets me to the 15. Here's just zooming in on writing the equation. So the vertical change divided by the horizontal change is equal to 3. That means that 3 times this amount is going to equal the vertical change. That's what that division tells you. When you get an answer of 3, it means that you have to have 3 of these values to get to this value. So y minus 15 equals 3 times x minus 1. This simplifies. You multiply this out. It's 3x minus 3. Add the 15. Subtract the 3. 15 minus 3 is 12. This is the vertical intercept, and this is the slope. Remember, this is y equals m, so 3 is the m, plus the vertical intercept, which is 12. Okay, now zooming in on that 12 inches head start. So this is the height when the plant was planted. It was 12 inches tall. So it doesn't make sense that the that the slope is 3 and that the head start is 12 inches. Well, if you go to this 12 inches and in 1 month it grows 3 inches, so that gets you up to the 15 inches in 1 month. So it does make sense that the vertical intercept is 12 with the slope or the change in the vertical change, which means the height that it's grown in 1 month is 3. So the vertical change compared to the horizontal change. Now, what if you are told that the plant has a height of 66 inches and you have to calculate how many months did it take to get to that height? So is that 66 inches? How long did it take, or how many months did it take to get there? Well, you have to subtract the height of the plant when it was planted. It was 12 inches tall, so you have to get rid of that 12 inches. So 66 inches minus this 12 inches gets you to 54 inches. So now the plant is 54 inches tall. Every month it grew 3 inches. So if you divide that 54 by 3, every time you take out 3 inches, that's 1 month. So how many times can you take 3 out of 54? In other words, 3 times what value equals 54? And whatever that value is, that's the number of months, because it grew 3 inches each month. Well, one way to look at that is to multiply, this is a little bit of algebra, to multiply that 3 times 1/3, and you have to multiply 54 times 1/3. So this is the reciprocal. This is going in the opposite direction. So you're given the number of inches, and how do you figure out how many months that is? How do you figure out x? So you divide by 3 or you multiply by 1/3. So 1/3 of 54 is 18. I actually like looking at it as dividing by 3 a little bit better in this case, because every time you take out that 3 inches, that's equal to 1 month. So how many times can you take out the 3? That's dividing by 3. That's equal to 18. So it took 18 months to reach a height of 66 inches. To work backwards, to work forwards just for a moment, 3 months at 3 inches for each month, that's going to get you to 54 inches. But then remember, you have to add the height that you started with. You started with 12, 54 plus 12 gets you to the 66.